Since there isn't anything common between these two denominators, I can't just like add 10 or something like that. I got to multiply. The only way to get these two common denominators is to multiply them by each other. And so when we multiply it out, this is what I would write out for my step. Now I say what I would write out because I go straight to multiplying out on the top. I go ahead and multiply the 4 into the x and the 4 into the 3 here to get 4x plus 12. Some of you will start by writing it out as 4 parentheses x plus 3. That's fine. However, you will eventually on that next step have to go into this form though, because in order to add them, I'm combining like terms. And I can't combine the like terms if they're all trapped inside of different parentheses. The bottom though, because it's going to stay the same, you can leave it in factored form. If you want to actually expand it out, you can, but you don't need to. So if I combine those like terms, I do the 4x plus the 3x, that gives me the 7x there, and then 12 plus a negative 21, that gives me the minus 9. And then I look at that and I say, okay, can the top of this factor at all? Can I factor 7x minus 9? No. And so because of that, this is simplified. This is as good as it gets, but it's not my final answer. Because remember, we have to include the restrictions. And so the restrictions, as you may recall from our last lesson, is anything that would make the denominator equal 0. That is, what makes the bottom equal 0? Notice the x minus 7 and the x plus 3 are the only possibilities. And so we end up finding that x cannot equal a positive 7 or a negative 3. Because those are the two numbers that would make the bottom equal 0. This then is the final answer, complete as we can make it. Now today we're going to be attacking problems that look like these. This is now combining two different aspects of the rational expressions and rational equations that we've been working with. Because there's addition involved, but there's also an equation involved that we'll have to solve. Now, one of the general rules of math that is a nice helper for understanding any kind of a problem is that if you're looking at a problem and it does not look like what you're used to working with, look to see if there's a way you can make it look like what you're used to working with. Now, in the past, we have been working with problems where we had something over something equal to a different something over something, a proportion. And we could solve those. Remember, that's where we would cross multiply. Well, this is the same idea. We can approach this problem the same way if we can make this into a single fraction. Can we make that into a single fraction? Yes, we can. In order to add fractions, I need a common denominator. I already have a common denominator here, so I just do the 1 plus the 2 on the top, which gives me 3. And then the x stays the same on the bottom. Remember, we need a common denominator because it stays the same. And so we have 3 over x equals 1/4. Okay, solve from there. And so to finish solving it out, we cross multiply. So I do x times 1, which is just x, equals, remember when we cross multiply, they're equal to each other. It's not a fraction now. This gets rid of the fraction. Then I do the 3 times the 4, which gives me 12. Look at that, it's already done. Having done that last problem, I think you can handle this one now. Because again, it's the same strategy. I want to make it into just a single fraction on each side. So go ahead and make that into a single fraction and then solve from there. Now once we have our common denominator, we go ahead and we add the two fractions. Remember on the top, I'm adding. It's really tempting, and the common error I see here is to say that it's 20x, but it's not 20x. We're adding them. So it's going to be x plus 20 on the top of the fraction. And of course the bottom stays the same from there. And now that we've cross multiplied, We have 2x squared equals 2x plus 40. We now need to solve that. Notice that in this equation that we are now trying to solve, at least for rid of the fractions, notice we have an x squared and an x in it. So really I'm just focusing on this quadratic. When I have a quadratic like this, what should we do in order to solve it?
0.
I'm going to set it equal to 0, yeah. Thankfully, this one did factor, so we get down to 2 times x minus 5 times x plus 4. And now we can talk solutions. How do we actually give our answers for these? Well, remember that the solutions are anything that actually makes this equal 0. Well, I'll take a look at this parentheses first because that's the first x I see. What minus 5 equals 0? 5, positive 5. If need be, you could actually write out the equation x minus 5 equals 0 and solve it. And that would also tell you that x would have to equal 5. All right, what about the x plus 4? What would make that equal 0? Yep, negative 4. Now a question about that though. What about the 2? What can I plug in for x that would make 2 equal 0? Well, if I plug in 0 for x, it would still be a 2. Because it's not 2x, it's just 2. So because it's just a 2, with no x there, the x does not affect it. And so the 2 does not give us an answer. The 2 just means that once I actually plug in, let's say 5, I'm going to be doing 2 times 0, which is still going to be 0. It doesn't change it. So the 2 not having an x with it doesn't affect what our solutions are at all. So at this point then, I have x equals 5 and negative 4. And after the work we've been doing recently, especially yesterday's work, the question then usually is, well, what about restrictions? Do I need to include any restrictions here? Well, our answer here is, what does x actually equal? Well, we found out what x equals. We aren't necessarily interested in what x doesn't equal, because x doesn't equal everything except for 5 and negative 4 in this case. But there is one way that we'll consider the restrictions in their own way. And this problem, it doesn't change our answer, but in other ones it might. Notice that the only thing that ever would have made the denominator equal 0 up here is if x had equaled 0. If we had somehow, at the end of this problem, had x equals 5, negative 4, and 0, if that had been a thing in this case, we would have had to say, wait, back up here we saw that x could not equal 0. And so we'd actually have to eliminate that as a possible answer. But in this case, we don't need to worry about it because 0 didn't come up as an answer. Neither 5 nor negative 4 would have ever been a restriction. And so we're okay here just stopping at this point.